uses sharp, very hot, and very cold materials and should be conducted with caution by audiences 12 and older with parental supervision. Hey y'all, welcome to Get Your Play Online. My name's Ahmed, and for today's Try It Out Tuesday, we're going to be making a pressure system in a bottle. Now some materials you're going to need to get started are your cup of room temperature water, your paper towel that you're going to wet with hot water, your scissors or your pen, your straw, your plastic bottle with plastic screw-on lid, your compressed CO2 gas if you have it, and your glue. I'm using hot glue, but you may also use regular Elmer's glue. Now step 1 is to take your plastic bottle and your puncher device and very carefully go to the lid and just poke a hole through. For step 2, I'm going to take my straw and put it through the newly made hole in the lid. I want about half of the straw above the lid and half of the straw in the bottle. Now for step 3, I'm going to close up the holes that I just made. I'm just going to take my glue and I'm just going to put some glue around the straw, covering up any holes. Just like that. Now I'm sure a lot of you guys are already familiar with the ideal gas law formula, PV equals nRT, or Pivner, as a lot of you guys probably remember it. And in this experiment, we're going to specifically be looking at the relationship between the P and the T, or pressure and temperature, in Pivner. So the ideal gas law formula tells us that P, pressure, and T, temperature, are directly related. So when P increases or decreases, T will also increase or decrease. And that is what we're going to be looking at this next step. So for this next step, we're going to have our cup of room temperature water, and then we have the bottle that we made in the previous steps. So currently, the temperature of the water in the cup and the temperature of the air in the bottle are the same. They're room temperature. So in this next step, we're going to show you that relationship in Pivner by decreasing the temperature of the air in the bottle and show what happens to the water in the cup. So now we're going to get to it. So we get our bottle that we made in the previous steps and turn it upside down. And what we're going to do is we're going to stick the straw into the cup of room temperature water, and we're going to have about like an inch of the straw into the water. And then after that, we're going to grab our CO2, turn it upside down, and then very carefully we're going to spray the bottom of the bottle and see what happens. So as you can see, water is being sucked up out of the cup and into the bottle. Now, why this is happening is because if you remember what we spoke about earlier with regards to Pivner, we've changed the temperature of the air in the bottle. And what we've done specifically is we've decreased the temperature of the air. And when we decrease the temperature of the air, we've actually made the molecules of air that's in here move much slower. When they move much slower, they're bouncing around the walls of the plastic bottle much less. And when there's less bouncing happening in the bottle, that means that there's less pressure in the bottle. And less pressure in the bottle creates this sucking sensation, which we saw here with the water going up the straw and into the bottle. And if you don't have compressed gas, that's fine. You can still see the experiment happen. All you got to do is put the bottle that you made in the previous steps in the fridge for about 30 to 45 minutes. Which I did earlier. And then you want to grab a rag that you wet with really hot water and just wrap the top of the bottle. And in doing that, you should see bubbles start to form in the cup of room temperature water. Now what is happening is we have increased the temperature of the air in the bottle that was previously frozen in the fridge. And when we increase the temperature of the air, we've also increased the pressure of the bottle, because now the molecules of the air in the bottle are moving much more quickly than they were when they were frozen. And when they're moving faster, they're bouncing around the bottle much more frequently, and that moving around faster is increasing the pressure of the air in the bottle. And when the pressure increases, it's pushing all the air out of the bottle, and we see that in the bubbles formed in the cup. So I hope you guys had fun learning a little bit more about the relationship between pressure and temperature, which we discovered in our pressure system in a bottle. So I encourage you guys to try it out on your own, make your own pressure system, and be sure to tag Get Your Play Online so that me and the rest of the team can check out your awesome work. Thanks for learning with me, guys, and I'll see you guys next time on Try It Out Tuesday on Get Your Play Online.